So as of now, we were understood that regression concepts as well as a little bit of classification algorithms, right? Logistic regression we understood, right?
Yes.
Okay. Now this time, what we will do actually, we'll go ahead with some kind of ensembling techniques, which is very, very, very important. Ensembling technique. Decision tree also I done, right? Decision tree. Am I done the decision tree or not? Hello. Decision tree project also I did it. Pavani, can you please confirm me? Am I done that those things? Decision tree concepts.
Yes, you have.
Okay. Then are you practicing or not?
Yeah, I am.
So tomorrow we have a small conversation over the phone call regarding about your job process. Okay.
Oh, okay. Am I going to get an email?
No, you can call me tomorrow around mm, 1 1 p.m. that time. 1 p.m. of MST.
EST? Eastern Standard Time?
Any time is fine at afternoon time. Okay.
Okay.
Okay. So this time I would like to talk about ensembling techniques. So here ensembling is nothing but as of now we've seen only single modules, right? Or single models, right? Or else algorithms, right? Now here what we can do, ensemble learning is nothing but is the method of using the multiple models actually. As of now we build only single model at a time. Okay, now what we can do instead of building the single model, so in in ensembling technique, people what they will do actually, they will do that multiple models, okay, to improve the performance of a single model. So you finally you're going to be giving the single model only, but the single model which is connected with multiple models. Okay, so the idea is to combining the predictions of multiple models to produce the more accurate and stable final predictions. There are several ensembling techniques including the bagging, boosting and stacking. These are the three type of algorithms are the ensembling learning only. Okay, now did you got that what exactly ensembling learning is doing? Ensembling learning means it is a combining the multiple models to produce the accurate and stable predictions for the final model. Okay, clear or not? I need
Yes.
that, I need some kind of, guys are not interacting well. Why? I need some energy, guys. It's a very nice topic. It can give you a lot of intuition. So if you know this thing, it could be easy to play the game with the machine learning. So for you only, I created this document. Okay, I'm spending a lot of time to give that best material and best projects. Hopefully you can try to be interact in the session. So, Pavani, tell me how the ensembling learning is working.
How is it what?
How ensembling learning is working. The principle of ensembling learning, simply.
Um,
I already told you, right? So, as of now, we've seen only creating the single model and getting the predictions about that single model only. Okay.
oh, okay,
But
okay.
ensembling learning, what it will do, first we are going to be creating the multiple models. Okay, from this all multiple models You're combining actually. Okay, so
Oh,
combining the multiple models and produce the best model. Okay, so as of now, we're just creating the, for example, this is my data. Okay, this is my data. So with help of this data, we are just applying the machine learning algorithm and we are just creating the model. Okay, and we are getting the predictions, right? But now ensembling learning, what it will do, we have a data. Okay, you have model 1, you're creating the model 1, you're creating the model 2, you're creating the model 3, and we're creating the model 4, right, with the help of the same data. Okay, and finally it might be combining this all and producing that best model. Clear or not? This is the way the ensembling learning is working. Clear?
Clear.
Yes, within that one, there are three type of ensembling learnings are there. One is the bagging and boosting and stacking. Okay, bagging, boosting, and stacking. These are the three type of ensembling learnings are there. Okay, so we'll go for understand one by one. Bagging is very very important. The reason is that most of the time, most of the algorithms are working with a bagging technique, random or forest. Random forest algorithm is the one example of the bagging technique, and boosting is the ada boost, XZ boost. Okay, gradient boosting, different kind of boosting techniques we have it, and stacking also we have a plenty of algorithms we have it. Let's go for understanding one by one. So how that bagging technique is working. So you know that ensembling learning, it will be combining the multiple models. Remember that formula, that principle. Okay, ensemble means multiple models, right? Now, bagging in the sense, bagging stands for bootstrapped aggregating. Boost, bootstrapped. Okay, bootstrapped or bootstrap aggregating. So this is the term which is very very important. Bagging stands for bootstrapping aggregating. It is the ensemble method that trains the multiple models independently on the different subsets of the data, which means that this is my data. Okay, this is my data or main data. So from this particular data, what you will do, we are going to be creating the bootstrapped sampling. This is sample data 1, this is sample data 2, s2 s1 in the sense sample data. So we are creating the sample 3 and sample 4. This is the way from this particular data we are creating the bootstrapped data. Okay, after that one, we are creating the model 1 and we are creating the model 2. It may be decision tree. Most of the time we are going to be using the decision tree for creating the individual models, or else you might be creating the different other models like navibase, or else support vector mission knn, different models also we are going to be using it. After that one, you should go for finding the average or else voting. So which is the model? So here this model is good, or this model is good, or this model is good, or this model is bad. For example, most of the these are the three models are giving the best thing. So voting, either we can go ahead with the voting system or else averaging. Okay, do that average. Okay, so based upon that one, you will be getting the results. Actually, this is the way the bagging technique can be working. Clear? Clear or not? So bagging stands for bootstrapped algorithm. It is ensemble method that can train the multiple models independently in a different subsets of the data. The final output, averaging or majority votes of the predictions of all the models. The most popular bagging algorithm is random forest. Okay, so bagging is the useful when the data is high dimensional. What is mean that high dimensional? When the data is having the more independent variables. Okay, when the data set which is having the more independent variables. Okay, and if it is a high dimensional and high variance, it will help you to reduce the variance of the model by averaging the multiple models. So this is the way the bagging technique will help you actually. Okay, so bagging is the technique. It will combining the multiple models, and finally we are doing that voting or majority voting or else averaging of your results. Based upon that one, we are finalizing actually. So we would like to go for using when your data is high dimensional and when we have high variance. So it will help you to reduce the variance of the model by averaging the multiple models. Okay. And bagging is less sensitive to noise and outliers than boosting. So boosting in the sense, boosting technique. And see what is the process of bagging is doing. Start collecting the data set. So you should go for collecting the data set. The data set naming, for example, D, and we are collecting the N observations. Okay. Now what I can do from this particular data set, I would like to do that multiple data sets actually. Creating the multiple data sets of the data by randomly sampling data set and D replacement. This is also known as bootstrapping. What is mean that bootstrapping? Random sampling with replacement. That we are calling it say bootstrapped. So after that one, with help of the each and every subset, we should go for train with the different models. So train a model independently on each subset of the data. The number of models is determined by the user. How many number of model you want to create and how many subsets you want to create, that's it depends on you only. Okay. And it will call it as the number of estimators. So based on the number of estimators, how many models you would like to go for creating as the base models. Okay. For new input, make the prediction for each model in the ensemble and combining them by averaging, taking the majority of the votes. So this is the graph you can easily understand actually. Okay. So you have a data with a label. So the data we are splitting into different samples: bootstrapped 1, bootstrap 2, bootstrap 2. This is sample 1, sample 2, sample 3. So with help of the sample 1, we are creating the model 1. With help of the sample 2, we are creating the model 2, and so on. We are creating the m number of models. And then what we will do actually, we would like to go that averaging and voting. So based upon this one, we would like to go for creating the bagging technique. Okay. See, the most popular bagging algorithm is the random forest. So which is an ensemble of decision trees. And so most of the time these models can be used decision tree, but sometimes we can able to go for using the Navi base and KNN and support vector mission, and those like those algorithms also we can use like a base models. So these models we are calling it a base model. This model 1, model 2, model 3, this we are calling it say base models. Okay. Clear?
Clear.
Okay,
Yes,
so
sir.
it is important as so this bagging technique we can use in classification as well as regression also. Okay, next one is boosting. So previously we seen this, you just see this graph, you can understand. Here we are doing the parallel approach, right? We are creating the model, parallel models. So you are creating all the models in one shot, and we are combining it final, right? So here it is the parallel approach. So bagging is the parallel approach, but boosting is the sequential approach. So boosting is the iterative technique that adjusts the weights of observations depending on the last classification. See, you just try to be observed here. So this is your original data. Okay, here we have one classifier, that means your model. Okay, so here we are getting some kind of results, right? Wrong results and correct results, right? And whatever the results we are getting the wrong, and that means we are updating the weights and we are creating the new weighted data. Okay, you are multiplying with weights with this misclassification, and we're creating the new weighted data. So with the new weighted data, we would like to go for again applying the machine learning algorithm, and here also we are getting some kind of predictions, right? Okay, the predictions are some are correcting, some are negative. Okay, that means wrong predictions. So from this particular wrong predictions, again we can do that weighting. We can apply the multiplication of weights and each and every misclassification, and we are creating the new weighted data. Again, this new weighted data, it could be input for the next classifier, and so on. We can do that. Okay, so this is the way you can able to go for weak learning to strong learner. Okay, so here in your data set, which are the data points are weak, We are targeting with that one only. Those learners we are making is the strong. Okay, with help of the boosting means giving some kind of strong. Who are having the weak, we are giving some kind of boost, right? In the same way, boosting algorithm is working the principle of giving some kind of strength for the weak learners. Okay, so this is parallel approach. So try to we go for understand step by step. It start by assigning the equal weights to all observations and then increasing the weights of the misclassified observation. Initially, we are giving the equal weights for all observation in your data set, and we are creating classifier, and there we are getting some kind of misclassification, right? That means wrong predictions. Okay, and that misclassification observations, we are increasing the weights so that the classifier focus on the observations that are difficulty classified. Which are the observations we are difficulty classify, so we are targeting on with that with that misclassifiers or with that observations. Okay, clear or not?
Yes, that's clear.
Okay, the most popular boosting algorithms are the okay ADA boost and boosting ADA boost and different other things we have it. And so this is the step you can just okay. So guys, we'll continue the stacking techniques with some example by tomorrow. Okay, and take care. Bye.
Anjan, can you upload the recordings?
Sure.